Hello everyone, I am back with the new concepts of physics vector chapter. Okay, previously we have discussed about a lot of things, so I'll just give a brief recap of it. Okay, first we discussed types of vectors like parallel vectors, anti-parallel, negative, opposite, unit vector, etc. Then we discussed about different types of laws. Okay, or basically vector addition laws. Okay, in that we first discussed the triangle law and then the parallelogram law, and then mathematical derivation of the formula like resultant vector is equal to root over a square plus b square plus 2ab cos theta. And then we also learned to find the angle between the resultant vector and the given vectors like tan alpha equals b sin theta by a plus b cos theta and tan beta equals a sin theta by b plus a cos theta. Okay, so today we are going to discuss about the polygon law. Okay, it is basically used for addition of two or more than two basically it is used for addition of more than two vectors. Okay, polygon basically means which has many sides. Okay, now the statement is like this: if some vectors are represented by the sides of the polygon, okay, in the same order, then the resultant vector is represented by the closing side of the polygon in the opposite order. Okay, so I'll let you see the figure. This will help you to visualize it better. Okay, see, there are four vectors: vector A, vector B, vector C and vector D. First we will arrange them in same order. Okay, so I have taken this vector B, put it here, moved it parallel, then vector B here, vector C there and vector D here. Okay, so basically vector A, B, C and D are in the same order and this is the resultant vector, closing side of the polygon. Okay, it is in the opposite order. Opposite order basically means tail of two vectors or head of two vectors. Okay, so resultant vector is equal to vector A plus vector B plus vector C plus vector D. Okay, now see, if there is a condition also in a closed polygon, if all vectors are in the same order, then the resultant vector is zero vector. See, like we have taken that vector A plus vector B plus vector D plus vector D plus vector E. See, all of them are in the same order. See, this vector E head to tail is connected and tail to head is connected. Then resultant of all this will be zero. Okay, I'll explain this. See, first we will take vector A plus vector D like this is equal to 0. See, now vector A, B, C and D together make vector R. Okay, resultant vector. So we will put it R, and we also know that vector R equals negative of vector E, because see, this is anti-parallel to each other. So this will give us vector R is equal to minus vector E plus this vector E. So this will give us 0. Okay, so if all the sides of a polygon are in the same order, then the resultant of all the sum will be 0 only. Okay, now there are some important points. The resultant of three vectors can be 0 if they satisfy the following condition. See, if vector A minus B is greater than equal to resultant vector greater than equal to sum of it, or basically sum of two small sides must be greater than or equal to the third side, then only the three vectors can be 0. Okay, now second thing is minimum number of vectors of equal magnitude required to produce 0 resultant is 2 vectors. See here, like in this diagram, there are two vectors of equal magnitude, vector A and vector B. Okay, now vector A is in this direction, vector B is in this direction. Basically angle made between them is 180 degrees. Then the resultant vector will be 0 vector. Okay, because see, both are in anti-parallel direction, so they will be forming a resultant of 0 vector. Okay, and minimum 2 vectors are required to make it 0 of equal magnitude. Next statement comes is minimum number of coplanar vectors having different magnitude required to produce 0 resultant is 3 vectors, which means basically we need 3 vectors of different magnitudes if we want to produce a resultant of 0. Okay, like see in this figure, there are 3 vectors A, B and C, and all of them are in the same order, head to tail, head to tail, head to tail. Then resultant is 0. We just studied the polygon law, means If all the vectors are in the same order, then resultant is 0 vector. C, then R will be 0, and all of them must lie in the same plane. Okay, and minimum 3 vectors are required of different magnitudes to produce resultant of 0. Now, fourth point comes is minimum number of vectors in different planes required to produce 0 resultant is 4 vectors. Means suppose like we have 3 axes, I cap, j cap and k cap. Okay, then if we want to produce a resultant of 0, okay, and vectors are in different planes, then we at least require 4 vectors. For suppose there are 2 vectors, like suppose in this case, okay, leave this 3 vector, just these 2. See, vector A and vector C. Okay, these 2 are in the same plane. Then suppose this vector D is exceeding out of the page, means in the upside direction. Okay, then this will be third vector. Then we will require a fourth vector which will connect the outgoing point with this point, which will give us a resultant of 0. Okay, or basically we can just say for closing the figure we will also need the fourth side, okay, which will be in the same order, then only our resultant vector will be 0. Okay, now next thing comes is property of vector addition. Okay, vector addition follows some properties. First is it follow commutative property. Okay, basically commutative means that if you add 2 vectors in the, suppose in same order, then if you change the order in addition, then also resultant will be same, like vector A plus B is equal to vector B plus A. Similarly, it follows associative property. Associative is basically if you are adding suppose 3 or more than 3, and first you are adding vector A plus B, then the sum which you get you are adding with C. It is equal to, if you are adding B plus C here, then the sum you are adding with A, then both these things will be equal. If you change the order of addition, or even if you add 2 vectors and then that to the third vector, or second and third vector then that to the first vector, then also resultant is always the same. Okay, now third thing comes is resultant of 2 vectors always lie in the same plane. Basically you all know that if see it is vector A and vector B, then suppose this is the resultant, then resultant will also lie in this plane only, it will not go in some other plane. Okay, now fourth point is if n coplanar vectors of equal magnitude are separated by equal angle of separation 360 degree by n, then their resultant is 0 vector. Okay, I'll explain this point in the next video. That's all for today. Thank you.